Hello, how's everybody doing? Welcome to our webinar on shifting left on cloud and AI costs. We have a insightful session planned for you guys, but we'll give it just about 30 to 60 seconds more to make sure everybody can come in. I see some familiar names in the waiting room already, maybe from FinOps X. It's always nice to see how great was San Diego this year. Feel free to say hello in the chat, tell us where you're coming in from. It's a Tuesday afternoon, so I'm going to give people a little bit more time. I know a lot of meetings running over, a lot of long lunches running over too.
Depends what time zone you're in, yeah.
Oh, that's a good point, yeah. A long breakfast maybe for some folks. Okay, we're just a couple minutes over, so I'll get us started. Yeah, once again, welcome. Welcome to Frugal's webinar on shifting left on cloud and AI costs. We have a fun session planned. We have Mike here and Craig who are going to be speaking. I'll start off with an introduction for both of them. So Mike is our co-founder and CEO. He's our in-house serial entrepreneur. He's on his fourth venture-backed startup, I believe. That's Frugal. And he previously founded Watchfire, which was acquired by IBM, and Blaze, which was acquired by Akamai. We also have Craig, who's going to be handling the more technical things. He's our CTO and co-founder. He is the pioneer, or he's pioneering the shift left cost engineering discipline. So the way he describes it is code level discipline for reducing cloud and AI spend earlier in the development cycle. But he'll get more into that. Little overview on the agenda for us. So like I said, Mike will be going over shift left, a little bit more of background context, what it means and why it's important. I think a lot of folks, especially if you're not from the engineering world, might not be familiar with how shift left has been used. So Mike will dive into some of that stuff. And then Craig will take on the more technical pieces. He'll walk us through what shift left cost engineering actually looks like in practice. We'll have some polls going out in the middle. So feel free to chime in. We'd love to learn about where you are in your shift left journey. And then we'll end with a Q&A. So with that, I'll pass it on to Mike, and you can take us.
Thanks, Ishan. Hi, everybody. Yeah, I'll walk you through a little high-level overview of what shift left means and why it's important, and then hand it off to Craig, who's going to do a deeper dive on real-life examples, walking you through what that might look like in practice. So the fundamental problem that we're trying to address is that most cost controls today are very reactive. Developers who are writing code often can't see the cost. They don't know what they are as they're writing software. We then deploy that to the cloud, and sometime later we get the bills. And when the bills become painful, we go back and we ask those developers to do something about that. But by that time, they've probably moved on to 5 other projects. It's really hard to get people's attention the longer it's, the longer an application has been in flight. And so the concept behind shift left is to move our posture from a reactive posture to a proactive one. And really what that means is moving cost visibility, cost analysis, cost optimization closer to where engineering decisions are being made. And the earlier that we can do that, the better. And the longer we wait, vice versa, the higher the waste that we're going to see. And so that's the basic idea. Now, we've learned this lesson before with other issues. If you look at security, quality, performance, all these are issues that once were the same as cost, but now we've learned that doing them earlier would be beneficial. So, for example, imagine if all the developers stopped checking for security vulnerabilities, prior to release of software. Would we be surprised that all of a sudden there's a lot more vulnerabilities to deal with in production? And so that the same is really true with cost. And the later we're addressing these issues, probably the more waste that we're going to see. And, there's maybe two types of waste to think about. There's sort of visible waste that we're kind of familiar about, idle VMs, unattached storage volumes, over provision hosts, and these things may be fixable in config. But then there's all these like hidden issues, which are, maybe we'll call them the under the waterline problems, where there could be architectural issues, there could be log bloat, there could be inefficient use of AI models. And these things are a lot tougher to find, but maybe be introduced, every day by developers with code changes, or they may be things that propagate over time. Like, for example, the architecture might have made a ton of sense economically when it was first launched, but now with the new usage patterns, there are new problems that we need to address. And so, in the field of quality, there's been a lot of studies done to quantify the benefits of finding issues early. And basically, the models all showed that it was 30x cheaper to find a bug in the requirements phase than it was to find that same bug in production. And really, the same is true in cost. And so you might sort of also proxy, this 30x cost for 30x effort, meaning that if I am finding a cost restructuring or issue in production, it's going to have to be, it's going to take 30 times more effort than if someone had sort of found that issue in the requirements phase. So that's the basic idea. We've also taken, I borrowed this slide from the FinOps Foundation, whereby, the idea is that the dotted line kind of represents the natural trajectory or the no FinOps trajectory of an application in terms of its unit cost over time. But that by introducing cost-aware decision-making into the design phase, into the implementation phase, and then in the operation phase, that we can bend the cost curve and to lower the unit economic cost of a given application. So a lot of what we're talking about is shifting left, meaning finding issues early. But really, I think a better way to look at this is more of a continuous feedback loop, in that during the design phase, we want to look at requirements, budgets, forecasts. What are the cost requirements there? What are the architectural choices that would be most economical? And then when we get into building the application, we want to understand the cost of code changes that we're making on an iterative basis. Is there a lower cost way to implement this? But then we want to follow those same applications into production and look at the actual costs that we're incurring, and how are the usage costs of the application holding up to our assumptions. Are the unit economics and usage patterns the same as what we contemplated, or maybe different and changing over time? And so the idea is that we want to give engineers feedback on costs early in the design phase as they implement things, but also following those same costs into production and giving summaries along the way. And so I'm going to hand things over to Craig now, who's going to walk you through a real example of how that might look in practice.
Thanks, Mike. Yeah, I'm going to sort of tell a little story here of two teams and how they work with cost in their engineering practice. Our characters for this story are Marcus and Priya. So Marcus is a senior engineer who's been working on building systems in the cloud for many years. Really careful, skilled engineer. Priya, same thing. She's been building cloud systems for quite a few years, knows what she's doing, is careful, skilled. But they're working in kind of two different organizations with two different approaches to cost. So Marcus is at Tallgrass. They have a pretty reactive approach to cloud cost management. And Priya is in an organization at Northwind where they've shifted left cost engineering. And as we kind of go through, what we're going to do is we're going to look at them both building the same system. So they both, for both companies, they need a system that allows their users and stakeholders to upload invoices to their website. And that application will take the HTML or PDF invoice, pass it to an AI service to extract the dollar amounts and the itemized line items, store those things into a database, and store the original out to object storage. So it's just sort of a simple service that uses a few different cloud services to be implemented. So they're both building the same thing, and we'll sort of look at how it looks for them in their different organizations. So what we'll do is look at kind of 4 moments in the development cycle. We'll check out how things look for each of them at the architecture phase at the very beginning. 1 month in, when they're starting to implement the components. Then we'll fast forward a few months to the system is live in production and there's a change being made to it. And finally, we'll look at it where it's been live for a while. The developers have moved on to other things, but things are happening in production. And we'll kind of compare how things look in Tallgrass versus Northwind at each one of those moments. So to get us started, we'll start at the architecture moment. So I mentioned the system. It's, this invoice processing system. The way this looks in Tallgrass is people go to a whiteboard and sketch out how this looks. We've got an application load balancer service sending traffic over to an invoice processor process that they're running on Fargate as a kind of a container on AWS Fargate. It's talking to Bedrock, where the Anthropic Sonnet model is hosted to do the AI stuff. It's storing data over into an Aurora database. It's storing the originals out to S3. So in Tallgrass, this is architecture. They sort of, okay, how are we going to build this, sketch it out, and they make a plan, and that is effectively the system architecture. Back before the cloud, when we went to go build a system like this, we needed to know how many servers we had to go buy, but we're living in the future now. This is cloud days. We just build it and see what it costs. It's a pay-as-you-go kind of environment. So that's the Tallgrass kind of approach. Just build it. We'll see what the bills look like as they come in. Things look a little different over at Northwind, where Priya works. There, they've decided that they actually do need to have an idea of what a new system is going to cost before it's all built. And so Priya does something that I've done before at different places I worked, called a cost model. And so what this is doing, and there's a bunch of pictures of this spreadsheet that are pretty small, but it's a spreadsheet that helps us understand the architecture of the system, how load fans out across the services that you're using, how you expect traffic to grow in time, what impacts that will have on the load that you're putting on the various cloud services you're using through time, how much those cloud services cost, and ultimately you get a dashboard that gives you kind of a model of what this new service will cost at the beginning and what it will cost down the road a bit as traffic grows. So to kind of summarize that spreadsheet that was a little hard to see, what we're doing with a cost model is getting a plan for what we expect to see in terms of growth, and understanding what usage that growth will drive across all the services that we're using, and then get pricing for those things. So in our case, we've got requests per second of the number of invoices coming in, the number of documents, the number of invoices per month, how many tokens that will generate at the AI system, how many tokens back will come back from AI. We're paying for all that stuff, how much we're writing to the database, how much we're storing to storage. And why it's important to have that model is you actually have quite a lot of different choices at pretty much every level of this application. somehow we have to run our own application. So we need some compute to run that. We could run it as a Lambda function. We could run it as a container on Fargate. We could run it as an EC2 instance, as well as a number of other choices. For the AI, we could choose which AI model to use. For the database, we could choose between like a fully managed database like Aurora or RDS, a sort of semi-managed database, I guess, or more of a document database like DynamoDB. For object storage, where we're just storing these invoice files, we have actually a bunch of options there as well. So even if you sort of say, okay, well, Northwind is an AWS shop, we're just going to choose from the things that AWS offers. There are still many choices to be made, and the cost model helps you figure out which choices make sense for the kind of current load and the projected load down the way. For Priya, it made sense to choose to run this on Fargate. The Sonnet model was good. The totally managed Aurora data, or sorry, the managed database Aurora was the easiest to deploy. And they were going to store all these invoices, but never really look at them. So S3 with infrequent access was a good choice, is the most cost-effective choice for storing those things. So kind of armed with a strong cost model, in Northwind, they were able to make good choices about which cloud services to use, and have a plan for how things are expected to evolve as time goes forward. This and in my experience, these things are one of the most valuable architecture documents that you can make, because they tell you more about how your system is really going to behave than most types of architecture documents. And actually, I was very pleasantly surprised to see that making these things is easier than ever. This has always been kind of an Excel or Google Sheets exercise for me in the past, but I was really impressed with how easy Claude Code made this and how well it came out. And actually, I have a skill that if anybody out there wants to, get a skill for their Claude Code or OpenAI ChatGPT work system to use to build these things, I'm happy to share that. I've got it up on GitHub. I'll paste the link into the chat a little later. Okay, so back to the story. So we've got Northwind and Tallgrass. And Northwind has shifted left on cost. And so at the architecture phase, they're doing a lot of planning and cost modeling for how to do it. Okay, we're going to fast forward now about a month further into the sequence. And now they're actually implementing this new system. So these days, how that looks over at Tallgrass, Marcus is pulling out his coding agent, giving it a spec for the service that he needs to have built, and letting her rip. There's some review, there's some checking out the results, but pretty soon he's got an implementation of this service. The gap, though, is that the coding system doesn't have much in the way of cost awareness built into it. It doesn't know, unless you prompt it, to worry about the most cost-effective way to do things. It doesn't have any data from your production system or know about your model. It doesn't have anything that would guide it towards a more cost-effective solution. Contrast that with Priya at Northwind. She's using the same coding agent, doing the same job of implementing this system. But her coding agent has a helper plugged in that knows all about cloud costs, and it has know-how of how to optimize for cloud costs. It knows about things like Northwind's actual costs and usage data that help it design a system that is cost effective from the beginning. So in this case, Priya's coding agent, she started exactly the same way with the same prompt, but what comes out in the interaction with the coding agent is some extra feedback to say, hey, there's a challenge with, or there's a cost problem with what you're about to do here. And here's a suggestion for how to build it in a better way that's going to have less cost impact. And so Priya is happy to accept that suggestion at this point. It takes very little effort on her part. But by bringing that cost know-how into the loop at this phase, we've basically built a system that from the beginning is more cost effective. All right, so we've done our architecture, we've done our implementation, we shipped the thing. I'm skipping over lots of parts, but we'll go to another moment a few months in. This moment, we are getting some feedback from people who are using the system, and we want to extend it to do something new. So someone's raised a request, oh, we're not handling duplicate invoice uploads very well. We want to do some detection when someone uploads something that we've already seen, we reject it or make an error message or something. So in Tallgrass, this is a pretty straightforward change. A new engineer in the team gets assigned the work. It gets implemented. Another engineer reviews the changes. Honestly, it all just looks looks good. It's simple. We're checking some things that are already in the system, but everything looks straightforward. The problem is that neither the engineer who did the change nor the one who reviewed it had the right cost context to predict what the cost impact of the change was going to be. The change happened to start reading documents off of S3 to see if they had already to see if that document had been seen before. But you may remember back at the beginning, the initial plan was that we weren't going to be really reading from S3 much. So we're putting those documents into an S3 bucket that isn't expecting to have a lot of read access. So we've sort of created a cost problem that you wouldn't necessarily see from the small code change from this enhancement. But for Priya, the situation is a little better. Same thing is happening over at Northwind. A new engineer is making the change, and it got reviewed, but it's gone into their GitHub that is plugged into with something that can do a deep cost review on every change. And that cost review knows that the S3 bucket that they're using, the S3 service that they're using, isn't designed to support frequent access. And so the change gets flagged that, oh, this change is actually going to have a significant cost impact. This is what we think the cost impact would be. And you get some choices for how to deal with it. Maybe the right choice is to move the bucket off of standard infrequent access S3 and move it to regular S3. Or maybe the change that's being made right now doesn't need to read from S3. So you get some help to figure out the right path forward. But the key thing is that in Northwind, this cost regression gets caught before it ships, because built into their GitHub, they're doing cost code reviews on every change. Okay, that's all good. Now, a few more months go by. Nobody's touched the code since that last enhancement. Everything is just running in production, and all the engineers are thinking about other problems at this point. How does this look in each organization? So at Tallgrass, somebody notices the bill. None of those things that we did along the way in Northwind to save money happened at Tallgrass. And it's not so much really a spike as just nobody noticed. And now all of a sudden they realize how much they're paying for this service, and it's out of line with what they think that service is worth to them. This gets executive attention. This becomes a big fire drill where engineers are pulled off work that they were working on and asked to go figure out why this service is costing so much, what we can do about it. Let's get this fixed as soon as possible. It's a bad day for the engineering team at Tallgrass. They were busy. They were right deep into some other problem, and now they've got to go figure out what mistakes had been made over the course of the last year that were driving up this cost. And where do they start? Like they've got to go start digging through metrics, cloud bills, maybe source code. It's actually a pretty complicated challenge to go reverse engineer this problem. Things look different over at Northwind. So the first thing that looks different is, as they've shifted left, they gained visibility into what their applications were spending. So the new invoice processing service that they built, it had a dashboard, and it shows for each of the services that invoice processing uses, like S3, Aurora, and AI, can see how much it's being spending on each of those at all times. And they get that on a weekly and a monthly basis. So that's easy for the team that built the service to watch and make sure, sort of track that it looks like what they originally planned in the model. And if it starts to deviate too much from the model, they can go take action, and they can get the detail automatically of what service is starting to cost more. So the first thing is, like, they have that visibility, and so there's no surprise at Northwind. It's more just well-managed engineering effort, like a lot of other things. The second part is that even with that visibility, running systems, things happen. Maybe a customer loads spikes up way more than expected in the model. Or in this case, maybe one of the services that the system is using changes. So for instance, AI models are changing all the time. People reference AI models directly in their code often. And so if you put out something and don't go back to it for 6 months, it's very likely that you're now using either an older model that is either about to be deprecated or is costing you more than a equivalently intelligent model that is available now. And so that happened in this case. So a new model was released in those 6 months where no one touched anything. And so say that they were at the sonnet level before, and now the haiku level is just as intelligent as the sonnet level was 6 months ago. By moving forward to the haiku model, they can save a lot of money. And so in Northwind, they get a frugal fix that detects that condition in production, sees that there was a change that the engineering team needs to know about, tells them what was found, what they can do about it, how much that would save. And this just flows into their issue tracking system and gets actioned like any other ticket in their system. So again, no surprise, and also they catch the problems as they emerge and fix them pretty quickly, as compared to kind of having them be live for a long time and it being a dramatic event to go fix them. So that's sort of the end of the story. What we looked at here were 4 different moments in the software development lifecycle, and what we did at each. At the architecture phase, we built a model so that we could choose the most cost-effective services for our current load, and make good architecture choices that were cost-efficient from the beginning. During the implementation phase, we had cost awareness built into our tooling so that we could make sure that we avoided falling into cost traps, that we sort of were using the services that we were using in an efficient way, and so that we could add in instrumentation for cost where we needed it to help with the visibility as we went. At a little while down the road, when we go to add a change into the application with an enhancement, we had tooling that helped us protect against a cost regression, where we had a code review happening as part of the PR process in GitHub that flagged that there was going to be a cost issue. And even further out, as the system, as things changed outside the system, customer changes, service changes, we were monitoring, and we were able to catch the changes that matter there to cost and make those a regular, task ticket for someone to work on, rather than it being a surprise later on. So these things all compound and made a big made a big difference in the cost savings. Didn't really require a lot more engineering effort, especially when you consider the fire drill that the other team the Northwind team would have to run. And it's all happening in a more smooth manner. So why shift cost left? If you do shift cost less, you get better visibility so that you know exactly how your code is spending. You get much better predictability, so you have fewer surprises when costs start to grow. You're going to have that visibility is going to naturally drive lower cloud costs, and it's going to be a smoother operating, more efficient engineering environment. This isn't impossible. This is something that every organization can do. And it's not about how careful your engineers are or how much they know about the cloud. It's really about making cost one of the things that engineering teams are building for. It's about teams owning the cost of the applications that they build. And that's only possible if they can see what costs that they are driving. So it's really important to get the visibility on costs out to the teams who are building things. And as we all are getting a little bit more disconnected from the code with our agents building more and more of our applications, it's ever more important that we have strong control systems around all of our applications. In this case, we need a strong cost layer that gives us a good way to understand how our applications are spending and to put controls on those things. So those are some of the reasons and what you get when you shift cost left.
Thanks, Craig. Thanks, Mike. And thanks to Marcus and Priya as well. I will open it up to questions. I think we are doing really good on time, so we definitely have some room for questions. Feel free to post in the chat directly if you have anything. We got first one from Joey here. Traditional FinOps was built around cloud provider infrastructure metrics like EC2 or S3, with modern AI spend moving heavily to external API keys like OpenAI or Anthropic. How do you catch runaway code loops or inefficient prompt patterns before they trigger a massive bill? I think that's more Craig.
Yeah, I think so. So for Frugal, we're doing a deep analysis of your source code to understand how it interacts with all the paid services that you use, including OpenAI and Anthropic. Frugal will also connect to your OpenAI and Anthropic bill, so that we have the bill to guide things. So with those 2 bits of information and sometimes some metrics, we try to triangulate as to which calls to AI are potentially running away with things or driving too much cost. And then we augment that with an instrumentation library that we ask, or that we offer for you to include around your AI calls. And with that, we get very detailed information about metrics on all your calls, so that we can see inefficiencies in your prompting style, inefficiencies in your output tokens, your reasoning tokens. We get metrics on all that stuff and can flag that to you to say, look, here's a call site in your application that is driving 80% of your cost, and 80% of that cost is coming from this particular prompting pattern that you're using. So Joey, let me know if that hit what you were looking for, the question you're asking there.
Got a couple more. Thank you, Joey. Aaron, do I need every developer trained on this concept, or do I have a centralized team to lead the effort?
I'll take that one. So I've worked in a few different places over the last couple of decades, and they've had varying degrees of this shift left cost stuff happening. In the places where we had pretty much this kind of shift left cost stuff happening, it was just, there wasn't training, it was just an expectation. If you were building a new system, not only did you have to have an architecture diagram, you needed a cost model. And you needed to make sure that you were including metrics that in your system that would be indicative of how much things were costing. So I think it's, I think as far as like, I don't know about training, but I think you need buy-in from engineering leadership to make it happen. And I think you need to provide the visibility into costs somehow. That's one thing that Frugal does. There are other ways, of course, but you've got to get the engineering teams to be able to see the costs that their applications are driving, and everything kind of flows from there.
Thanks, Craig. Hope that answered your question, Aaron. I think we'll move on to Taylor here. So for a team that's already done the infra right sizing, how much is typically left in the application layer? I guess either of you could take that one.
Yeah, I think it would really depend upon the application and what the workloads look like. Obviously, if you're a AI native application, you're going to have a higher percentage of AI costs. But typically what we've seen is, over the last 20 years since cloud launched, infrastructure moved from being 90% of everybody's application costs to a lesser percentage over time, as people have taken advantage of managed services, whether they're AI or other things prior to AI, like managed databases, Lambda functions, all this sorts of stuff, and would really depend upon the nature of the application as to how much potential there is to optimize application code versus infrastructure. Craig, is that anything else to add to that?
No, that was great. That was great.
Awesome. And then we have one from Art here. Does this work without an AI coding agent like Cloud Code already in place?
Yeah, certainly. Frugal integrates in with the coding agent if you're using it, so that that knowledge that we intend to bring to a developer is also available to their automated developer. But if you're a human, no problem. We've got a web app for you. We have a command line for you. We have all the different ways to get the same data. And the PR review would always integrate into your process as well, so that you could have Frugal reviewing every change as it goes into your source code control system, either as a pull request in GitHub or a merge request in GitLab.
Perfect. Hope that clarifies, Art. And I think we have time for one final one, and that's from Amir Hamza. How do you convince a CFO, CTO, or CEO to prioritize shift left when the cost is still only a line item in the forecast rather than an invoice they're already paying? Security gets executive attention because the risk of a breach is obvious and immediate. With cloud costs, the value of prevention is harder to see, and there's no dramatic "we caught it" moment. So how do you get leadership to pay for preventing waste before it shows up in the bill? It's an interesting one.
Yeah, it's a really good question. I think it is probably a struggle for most organizations that some of the data that we provided at the beginning of the presentation, and I think we'll circulate afterwards, right, Ishan, replay of this, but talks about a little bit about the economic cost benefits there of catching issues early. I think also that most executives get the idea that they want to be proactive about cost issues. And I think this is becoming maybe a more visible issue in the age of AI, where everybody sees these token costs kind of going up like crazy. And maybe it's an easier argument and decision to make when the variable costs of delivering delivering your application are that much more material. There's also a lot of benchmarks out there that you can put forth to understand how efficient your system is. An average technology company is spending roughly 10% of their revenue to deliver their cloud costs, whereas a less efficient system could be up there around 20%. Best in class is really around 3 to 5%. And so looking at these benchmarks and understanding, where are your costs relative to those benchmarks might give you an argument as to sort of how much better that they could be, and that economic kind of argument to your execs to understand maybe how efficient are we running relative to what is possible. Craig, anything else you would add to that?
No, that was it.
Awesome. Okay, well, we loved having you guys. Thank you for chiming in with all of your questions and participating in the polls. Thanks, Mike and Craig, for walking us through all of this. I will share a link with you guys if you have any more questions, or if you want a free cloud waste audit. We help out with that. So here's the link to book some time with us if you'd like to chat. But otherwise, thank you very much. Thanks, everyone.
Thanks, everybody.
Bye-bye.